Give me the thumbs up when you're ready. All set. So hi, everybody. My name is cs1nachenberg, and I am a what's called a fellow at Symantec, which is a senior engineering position. And I'm also adjunct professor here at UCLA. And in fact, if you like this talk, then maybe you'll want to enroll in my class, because I'll be teaching in winter, CS32, starting in January. So I'm hoping that I can convince a lot of you to take my class. It'll be very exciting. Now, this in CS1, you learn about great ideas in computer science, about all the different things you can do in computer science, and I'm here to represent computer security. So I want to share with you some of the cool things about computer security. And I think, I used to do a talk that talked about the different types of security and how we would protect users. But in fact, what I decided to do this time is talk about an amazing security threat, a virus, if you will, something like a computer virus, because it demonstrates all of the possible things that can happen if we don't protect our computing infrastructure appropriately. And so I think you'll find this fascinating. This is all true. However, some of the things I'll talk about, I'll tell you when I don't know if something's true. In other words, there's something that's speculation here, some things that are speculation, and some things that we know are absolutely fact. Okay? So without further ado, what is Stuxnet? So Stuxnet is a computer worm. Okay? And a computer worm is an autonomous program, a piece of software that spreads from computer to computer over a network. So it actually spreads itself, it copies itself over the network. Stuxnet is roughly 50 times more complex than the typical computer virus or worm that we normally see. Okay? So it's an extremely complex threat. And how many people have heard of Stuxnet before? And how many people have any detailed knowledge of it? Okay, so we'll talk about that. It should be really interesting. As it turns out at Symantec, where I work, some of my colleagues, Eric Chin, who's actually a former UCLA grad, he studied electrical engineering here, was one of the people who dissected this threat. And in fact, when he dissected it, he got so nervous because he understood the implications of this threat that he would actually look under his car for bombs. And so you'll see why that's the case in just a second. So this is Natanz, Iran. Now, I don't know how many people have heard of Natanz, but this is actually a place in Iran where they enrich uranium. Enriching uranium means they basically take raw uranium, hexafluoride I think it's called, and they spin it inside of centrifuges in order to refine that uranium, get rid of the other compounds so they can use it for potentially nuclear power plants or nuclear weapons. Okay? This is an aerial photograph. And these are centrifuges. They're not Natanz's centrifuges, but they were a really good picture from Google image search, so we'll call them Natanz's centrifuges for now. And the way these centrifuges work is basically on one side, let's say here on the bottom, you introduce very unrefined uranium gas. Okay? And actually that uranium gas has two different isotopes of uranium. Okay? It has heavy uranium and light uranium. And what happens is that these centrifuges, these centrifuges spin, okay? And the heavier uranium goes to the outside, and the lighter uranium goes to the inside because of centrifugal force, right? And then what happens is each of these is connected to the next. So the heavier uranium goes to the next centrifuge in the series, and it spins it again. It basically progressively spins the uranium until it becomes more and more refined, and you separate out the heavy and light isotopes. Okay? So this is what they're doing in Iran, and probably elsewhere around the world. Now, this is what this all looks like. Okay? So here we have the centrifuges at the bottom. Okay, that actually spins the uranium gas really fast. Okay? But at the top, you see there's a lot of other things that are involved in enriching uranium. So the first thing we have is a Windows PC. So believe it or not, uranium enrichment takes place using a Windows computer. Okay? So that Windows computer controls some software called Step 7, which basically orchestrates the entire enrichment process. Okay? So how many people think that Windows is really secure? Okay, that was no one. Okay, so you can tell that this is probably a problem. Now the Windows computer is directly connected by a wire to something called a PLC, or programmable logic controller. Now what this is a separate piece of hardware. It's a separate CPU. It's a separate chip, a separate box. It's not at all related to a Windows PC, and it runs effectively embedded software. It runs its own machine language, its own assembly language, its own software in order to control this entire system. Okay? So there's the PLC. It's a specialized piece of hardware that orchestrates control of all these connected devices. Now, that PLC can't connect directly to a centrifuge. In fact, we can connect many centrifuges to that PLC, and that's exactly what happens in Iran. Basically, these devices here are routers, okay, network routers. And what these do, they're called communications processors, is they forward the traffic from the PLC down to the centrifuge, okay? But that's not it, because when you plug one of these centrifuges in, the wall frequency is 60 hertz or 120 hertz. That's what the frequency of the electrical signal is. So you have to step up that frequency using frequency converters in order to get it to 1,000 hertz, which is what the speed needs to be, 1,000 rotations per second, in order to enrich uranium. Okay? Make sense? So these step up the electrical signal so that we can actually spin fast enough. And finally, we have the centrifuges that spin that uranium hexafluoride gas. Okay, so this is what we believe is happening in Iran, in Natanz. Now, I didn't actually go in there, so I can't prove this, but this is the intel that we have. Now, we believe, and this is again conjecture, that they are also isolated. And so what this means is there are actually two networks, and they're little green soldiers that protect one network from the other. Actually, they're probably not green, but that's again the PowerPoint animation that the icon that I used. But basically, we think there's a research network up at the top here, which is used to research new algorithms, to improve the operation of the centrifuges, to make improvements, to fix bugs, and so on. There might be email on this network here, and so on. But it's totally separated. It's what we call air-gapped from the bottom network. Air-gapped. That means there's no wired connection, we believe, although we're not sure, between the two networks. So unless you go by a guard, you're not going to be able to get in there to infect it with a virus, for instance. Okay? Now, this is a picture of somebody from the Mossad according to Google image search, so that's good enough for me. So we're going to use him as a proxy, okay? Now the Mossad, if you don't know, is rumored to have been part of Stuxnet, okay? Because Israel doesn't want Iran to have nuclear weapons. And so it is believed, although I'll tell you later what the truth is, or what we think the truth is, that somehow the Mossad participated. And this guy right here, or somebody like him at least, probably not him, because that would be pretty silly, wants to introduce this, a digital time bomb, onto this computer right there, that Windows computer, because we know how to attack Windows, okay? And that's what he wants to do. So how exactly does this digital time bomb, get onto an air-gapped network, which is totally separated with no wired connection as far as we know, to disrupt these centrifuges? Well, let me tell you. First of all, the threat has got to spread on its own. So this worm, this Stuxnet worm that we're talking about, there's nobody that's going to be able to carry it in and say, oh, let me just stick this virus on your computer. So it's got to spread on its own until it gets there. Until it discovers the proper computers. So it has to make sure that it's actually on the right computers. It doesn't want to disrupt computers that are not uranium enrichment computers. Where it can then disrupt the centrifuges, it'll actually do the disruption once it knows it's on the right computers, all while evading detection. If any of these things are not present, if it doesn't do any of these things, it's not going to be successful. If it didn't discover the proper computers, it might damage all kinds of other hardware. Okay? If it didn't disrupt the centrifuges, well, then why would you be doing this? And if it didn't evade detection, you'd find it and you get rid of it right away. Stuxnet did all of these things, and I'm going to tell you about them. So Stuxnet's got to spread on its own. So Stuxnet uses 7 distinct mechanisms to spread to new computers. I'll tell you something, when we typically see a computer worm, which again spreads over the network from computer to computer, it typically spreads using one technique. Stuxnet used 7 different techniques. What were they? Okay. So assuming that Stuxnet somehow made its way onto one of these computers, maybe a spy brought it in. Maybe somebody dropped a thumb drive onto the ground outside of the enrichment plant and somebody picked it up, a scientist picked it up and stuck it into the computer over there to see who happened to, maybe somebody owned it and they lost it. Okay, we don't know how it got in, but somehow it got into one of these computers. Once it's on the computer, Stuxnet copies itself to open file shares. So you all share files, right? You map your C drive, for instance, so other people can log into your computer and copy files from your computer. See pirate music, probably. Okay, that's not good. Okay, so what Stuxnet did was if it found another computer on the same network that had an open drive share, it would copy itself to that computer and install itself and run itself on that computer. So boom, now it's on 2 computers. Okay? Stuxnet also attacked Windows print servers. So what does this mean? Well, your computer can connect to your computer if you want to print something out. If your computer is connected to a printer, I can connect to your computer and print something out from your computer, but I can also attack your computer through that printer connection. Okay? And so Stuxnet used a hole in the Windows printer service in order to break into machines like that. And by the way, this is conjecture, we don't know this, but it is conjectured that there might have been a shared printer between the two networks. In other words, the worm could have potentially attacked a printer that happened to sit and be connected to both networks, and once it was on that machine, it could then spread into the interior network. We don't know if that's true or not, but we think that might be true. So this is one possible way it spread from the outside research network to the inside network. Windows attacked a hole in what's called Windows RPC, or Stuxnet attacked a hole in what's called Windows RPC. Now, what does this mean? Well, computers can actually often talk to other computers to perform activities. For instance, one computer wants to ask another computer to perform some function for it. Okay? This is done using something called RPC, or Remote Procedure Call. Okay? So there was a bug in that system, and so if one computer connected to another computer and said just the right commands, it could actually attack this computer and install Stuxnet as well. Yet another technique that it used in order to spread. In addition, this one's a good one. Okay, so you remember that Step 7 software I told you about? That Step 7 software which controls the PLC? Well, that Step 7 software and other software from Siemens actually had a bug in it. Not a bug, I take it back. It had a default installation, so when you would install that software on a computer, okay, it would install a default password for the database software for that product. Okay? So the password might have been password, for instance. So if you knew that that software had been installed in the computer, you could connect to that software, type in the default password, which was always the same, okay, and then log into that computer and attack that computer through that default password. That make sense? So basically, if you don't disable the default password when you install that software, then you can break into a computer running that software. And guess what? Stuxnet did. So it actually found WinCC databases, which are the databases used by this Siemens software, and it would then connect to it and copy itself through that backdoor by typing in the default password, just guessing the default password. Wow, well look at that. It also infected PLC data files. So you're all using Visual Studio, right, to program your projects, right? Visual Studio has solution files and project files. It has data files. Well, the Step 7 software that you use to program these centrifuges also has data files just like Visual Studio. So if you share your project files with somebody else, for instance, that's normally nothing would happen. But Stuxnet would actually infect those project data files as well. So if you shared your project with somebody else, Stuxnet would automatically spread with your project files onto the new computer. Okay? So it attacked anybody who shared information on how to build, for instance, centrifuge software would automatically get infected if it was on anybody's computer. Pretty impressive. Okay, so it's infected that way as well. Okay, and by the way, it also had a peer-to-peer updating mechanism. So what does this mean? Let's imagine that most of these machines can't connect to the internet. But let's imagine that only one machine can connect to the internet, or maybe one machine has been updated by a spy to a new version. So for instance, what if this version has been updated by a spy to version 2.0? Or maybe it happened to be able to connect on the internet to update to version 2.0. Well, guess what? It will automatically contact all of its peers in the network and update them as well so that they all run the latest version as well. Pretty impressive stuff. Now, if the centrifuges were air-gapped from the network, right? In other words, they were totally separated here. How could Stuxnet jump the enrichment gap? Well, guess what? I've only talked about 6 things so far, so here's number 7. Stuxnet will also spread over USB drives. So all it would take would be somebody to take a USB drive, okay, walk over to one of these machines, okay, walk into the enrichment network, and by the way, this would be somebody entirely entitled to be in the enrichment network, and boom, stick the thumb drive in the machine. That machine is now infected as well. 7 different techniques, 7 ways to get in. Questions afterwards if it's okay. Sorry. Okay. Now, furthermore, what's even more interesting is that 6 of these targeted flaws that it used in order to spread itself and break in were unknown to the computer security industry until they were discovered in Stuxnet. 6 of 7. Usually we're surprised when we see a threat using one technique in order to break in. Okay? So this just shows you the level of sophistication. Now what I'll tell you is that nothing that this did is science fiction. In other words, everything that it did is feasible, it's understandable. Any of you could do it if you spent a couple of years learning this stuff and doing it. But the fact that it did all 7 of these things is extraordinary. Okay? Not one of them is extraordinary, but the fact that it did all 7 is extraordinary. I'll take questions after. Usually I would take questions during class, but because I have to get through this, I want to just write your question down. We'll do it. Okay, it's a long talk, so I want to get it done. So we just learned how Stuxnet spread. Now let's see how it discovers the proper computers. So Stuxnet is extremely picky. It only activates its payload being disrupting the centrifuges, when it finds an exact match. Okay? So first of all, when it gets onto a computer, a Windows computer, the targeted computer must be running that Step 7 software. If that targeted computer is not running the Step 7 software from Siemens, then it knows it's not in a computer that controls centrifuges. So it has to find that software. But guess what? If it finds that software, that's not enough. Stuxnet is not happy. So Stuxnet, by the way, will spread to your computer and your computer and your computer. It'll spread on every computer that it gets access to, but it will only start doing things if these criteria are met. In other words, it wants to spread all over the place until it finds the right computer. So it hits your computer just accidentally, okay, or it spreads to it, checks to see if you have that software. Now, assuming you have that software, that computer must be directly connected to what's called a PLC, or programmable logic controller, which we talked about. And by the way, that PLC must have a model number of Siemens S7315. Has to be exactly the right model number. That just happens to be the model used by the Iranians. Huh, okay. But guess what? That's not enough. That PLC must further be connected to at least 6 network modules. These are the routers we talked about, of the type CP342-5. So it fingerprinted the hardware. It actually talked to the hardware and said, hey, are you the right hardware? And are there enough of you? Okay, are enough pieces of hardware connected? And finally, each network module had to be connected to roughly 31 Ferraro Pi or Vacon NX frequency converters. These are the things that up the frequency so you can spin faster. Okay? It looked for all of these requirements. It was actually able to query the hardware, the PLC, to find out whether it was connected to this hardware. Now, here's the interesting thing. If you do the math, Stuxnet verifies that the discovered PLC right there, that PLC is controlling at least 155 total frequency converters, the guys here at the bottom that spin the thing fast enough. And recently, we learned that Iran's uranium enrichment cascade just happens to use exactly 160 centrifuges. So they're exactly fingerprinting the number of devices that have to be connected in order to attack the system. If they see less than that, they know they're not dealing with the centrifuges. Okay, what a coincidence. The creators of Stuxnet must have guessed all of these details. I mean, I wonder, right? They probably had somebody on the inside. There was something going on here. Now, Stuxnet gets down to business. It's on a computer that it knows controls, almost certainly, uranium enrichment. But it's not sure, not entirely sure. So Stuxnet starts by downloading malicious logic onto the PLC hardware. So remember, Stuxnet right now is on that Windows computer, but what it does next is it actually copies itself to the PLC. So it takes a little mini-me there, and it throws it on the PLC. Now, what you probably didn't realize, well, I did say it earlier, but you probably were like half asleep because you're students, is that PLC is actually running an entirely different processor, an entirely different chip, entirely different languages than the Windows PC. It's not the same operating system. It's not even the same machine instructions. And so what that means is whoever built Stuxnet had to go and actually design 2 threats. One that would work on the PLC controller with its specific machine languages, and one that would work on a Windows PC. And in fact, this is the first threat we know that targets an industrial control microchip, or even really 2 different types of hardware. Okay? So that's pretty impressive. Now, next, Stuxnet doesn't start disrupting things right away. Stuxnet measures the operating speed of the frequency converters. So what it does is it says, okay, I'm going to just sit here and watch what's happening. I'm going to be very patient and watch what's happening and see how fast are these spinning. And it does so for 13 days. It literally does nothing. It just sits on that controller and watches how fast these centrifuges are spinning for 13 days. So as they're spinning, they're sending up telemetry to the PLC saying, I'm spinning at this rate, I'm spinning at this rate. And it sort of looks like this with nice little green balls. It really looks like green balls on the network. That was a joke. Okay. So Stuxnet is measuring all that telemetry, and it's saying, oh, these things are spinning at this rate. Maybe they're spinning at 50 hertz. Maybe they're spinning at 1,000 hertz. It's measuring this. Okay? And it makes sure that the frequency converters are spinning the centrifuges, or what it thinks are centrifuges, it's not sure yet, between 807 hertz and 1,210 hertz. Okay? Now, this is coincidentally the frequency range required to run centrifuges. That frequency range is the only frequency range that you can use to spin uranium. Okay? So it's looking to make sure that these devices are spinning at the right speed. After all, whoever wrote Stuxnet wouldn't want it to take out a roller coaster. because that would also be a system that might be connected to a PLC. But that wouldn't be running at 1,000 hertz because you'd probably be shot into the air. Okay? So as it turns out, when our team discovered that it was looking between 800 hertz and 1,200 hertz, they actually figured this out by reverse engineering the software. That's when my friend Eric started looking under his car. Because the only devices that run between 800 and 1,200 hertz are devices for enrichment, and they're export controlled. In other words, you cannot even get them out of the United States legally because they can only be used for one purpose, and they don't want them getting out. So at this point, imagine if you were analyzing this threat and you said, holy crap, these things are going after industrial, or sort of nation-state uranium enrichment systems. I mean, he still looks under his car. It's pretty funny, actually. Or maybe it's not. I don't know. Sorry, that's a little bit inappropriate. We're good friends. We're good friends. Now, Stuxnet is now sure. It knows it's on a machine that's connected to a PLC that's connected to 155 plus things that are spinning at the rate that would only be used to spin uranium. So now what it does is, after 13 days of recording these readings, it then raises the spin rate to 1,400 hertz. So watch the excitement here. It sends a command to all these frequency converters, says, you know what, 1,000 hertz isn't good. It raises it to 1,400 hertz. And in fact, it doesn't actually get to 1,400 hertz, we believe, because you can't spin up these centrifuge tubes, which are really big tubes, that quickly. They take a while to increase their rotational speed. So it maybe spins to 1,300 hertz before it actually stops spinning. So it only does this for 15 minutes, okay? So it just spins faster and faster and faster for 15 minutes, and then guess what? It brings it back down. Okay? So it brings the speed back down after 15 minutes, and guess what? Stuxnet then goes to sleep for 27 days. Doesn't do a thing, goes to sleep. So imagine if you're the guard that's monitoring those centrifuges, and all of a sudden you're like this, and you go to get somebody, you come back, and all the centrifuges are normal. That's what they did. They were messing with them. Then, after 27 days, Stuxnet slows the spin rate to 2 hertz. 2 hertz 2 times a second. Boom, 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 like that, instead of 1,000 hertz. For 50 minutes. 50 minutes. Okay? So it sends a command. Watch the needle. Goes down to 2 hertz. And guess what? After it does that, well, Stuxnet's patient, so it then, after it returns to normal for 27 days. And then 27 days later, speeds it up to 1,400 hertz. 27 days later, slows it down to 2 hertz, and on it goes. Okay? Next, okay, so Stuxnet repeats this process over and over. So, here's the question. Why push the motors up to 1,400 hertz, or roughly 1,380, I think is the maximum we think it would hit in 15 minutes? Why would you do that? Well, as it turns out, 1,380 hertz is a resonance frequency. You know what a resonance frequency is? Anybody drive a car here? Anybody have a car? You ever sometimes go on the freeway and your car gets on a bunch of ruts and they're just sort of repeated ruts and your car just starts vibrating? You know what I'm talking about? Well, that's what we think happens at 1,380 hertz with these tubes. If you spin them to that speed, they will start vibrating to the point where they will actually explode. We haven't verified this. I don't have one of these things in my lab. But that's what we were told by experts. Now, why reduce the motors to 2 hertz? Anybody have an idea? It's not a resonance frequency. What's that? No. Well, the uranium would settle, probably. But why else would you make it 2 hertz? Any other ideas? So let me ask you a question. When you spin a top, okay, what happens when the top slows down? It wobbles. It topples, right? So imagine, okay, these centrifuges, which are sort of spinning, but they're spinning very slowly, we believe it is to damage the physical mechanism that's holding it to the ground or to the bottom base of the centrifuge. We don't know, okay? But that's what we think. Okay, so what about Iranian failsafe systems? You're probably thinking, well, the Iranians, they're not stupid. They probably had monitoring systems to monitor these enrichment tubes. So how could this all happen? Wouldn't the monitoring systems just go off and blare sirens? By now you're thinking that the alarm bell should have been blaring, right? So perhaps Stuxnet pulled a Mission Impossible. Perhaps what happened was somebody put like a digital version of a picture in front. So something's happening, but the guy who's like watching the terminal, he didn't see anything going wrong. That'd be pretty funny, right? That'd be pretty funny. But in fact, that's exactly what Stuxnet did. So if you recall, Stuxnet was recording the readings for 13 days before it did any damage. 13 days. It actually saved those readings. It saved those readings. Now, even though there were fail-safe controls on that Windows PC, okay, and even though this would trigger a shutdown if the frequency ran out of range, in other words, if the frequency went too high, Stuxnet took care of that. And how did it do that? Well, as I told you, it records that telemetry when it's operating normally, when the systems are operating normally, when it's still fingerprinting. So what's happening is it's actually recording those readings. And then, when Stuxnet's ready to get down to business and start disrupting things, watch two different things. Here's the monitoring system that thinks what the speed is actually, or the speed should be. Here's the real speed of the centrifuges. Watch the difference between the two things. So Stuxnet then sends out a command that says speed up. Okay? This one goes like that, but notice the telemetry being pumped back to the Windows machine is the original telemetry. Everything looks like it's running as usual. Okay? Pretty clever. That's pretty amazing. Now you might also think, well, there was probably like a fail-safe big red button, so that guy who's in the room when the things start shaking can go hit the button. But guess what? Stuxnet cut that digitally, so you can hit that thing all you want. You could be on The Price is Right, doesn't matter. Jeopardy, nothing's going to happen. Okay? Can you imagine that? I mean, it's pretty scary what these guys did. Whoever did this. Now, to do this, Stuxnet has to evade detection, because if at any point on the path it actually gets detected, it's going to be stopped, and then it can't do its damage. So Stuxnet, of course, always does things in 5s or 7s, right? You can never just do one thing. So it used 5 distinct mechanisms to conceal itself. Number 5, Stuxnet hides its own files on infected thumb drives using what are called rootkits. A rootkit is a piece of software which basically hides itself and other software on a computer system. So if you're infected by a rootkit, you wouldn't know you have the rootkit, and you wouldn't know that there's something else in your computer system that it's hiding. It actually hides the files. So imagine if you had a thumb drive that had Stuxnet on it, and you plugged it into a computer and looked at the files. Okay? This is what is actually on the drive. You'll see there might be, for instance, the user's real files. These are the legitimate files that are not part of Stuxnet that you might have on your thumb drive. And then here are all the copies of Stuxnet files. Stuxnet actually had 6 distinct files that it used to spread, okay, that were on thumb drives. Okay? But once you stuck this thumb drive in a computer, here's what you'd see. It would actually hide its own files the moment you'd stick that in. It would actually automatically take control of the computer, okay, and hide the files. Now, I'll tell you an interesting story. So these temp files, I believe, I'm not 100% sure. This is the threat itself. These are the thread itself. Actually, I think these are the thread itself. The actual executable file, the malicious file. These other files are called links, link files. You know what a link file is? Typically, a link file links to another program somewhere else. So you double-click on the link on your desktop. It runs this program in this other folder. That's what a link file is. Okay? As it turns out, the people who built Stuxnet found that there was a bug in the link file processing software in Windows. So every time you stick a thumb drive in, or any drive in, Windows will look at each of these link files and open each of these files up automatically without you doing anything. It'll just look through all the files and open them up, and it'll read the file. And it reads the file in such a way that it's buggy, okay, in such a way that if the file is malformed, if the file is actually put in a certain format, which is incorrect format, it will actually trick Windows into running the attacker's code. Okay? So this file right here, for instance, was for Windows XP, I think. Okay? This is for Windows XP. So if none of these files were present, just these two top files, and this file here was present, and you stuck this in a Windows XP computer, when Windows opened that file, it would automatically launch the malicious software. Okay? Can anybody guess what these other 3 files were for? That one was for Windows XP. Windows Vista, Windows 2000, and so on. They had actually come up with separate attacks so that if you stuck this thumb drive into different versions of Windows, it would attack each version correctly. So even though this version wouldn't work on Windows 7, this version would work. Okay? Again, multiple levels of redundancy. Okay? Number 4. Stuxnet inhibits different behaviors in the presence of different security products. So Stuxnet is not stupid. It realized it was going to be running on the same computers with security software. It knew that it was going to be running on systems with Kaspersky software and so on, not Norton software or semantic software, because we're export controlled. We don't actually go to Iran. But other countries can sell to Iran. And so Stuxnet actually inhibited behavior. So imagine we had 3 different products running on a machine, or running on 3 different machines. Okay, on machine A, Stuxnet would actually inhibit, for instance, behaviors A and C, because it would know that A and C would actually trigger the antivirus software. Okay? With Kaspersky Internet Security, it would inhibit a different set of behaviors that it would know would trigger Kaspersky. Okay? So it would actually do different things in the presence of different security software. And with respect to McAfee, it didn't have to inhibit anything, because obviously everything would work. You know, it couldn't do it. So, I'm just kidding. I'm just kidding. It was a joke. I can't help myself. Okay. Okay. Sorry. I'm sorry. It's very inappropriate. I'm sorry. Sorry, Terry. I apologize. Very inappropriate. Okay. I can't help myself. Okay. Number 3. Stuxnet completely deletes itself from USB keys after it's spread to 3 new machines. So what it did was, it would actually spread to new machines every time you'd stick that USB disk drive in. But then after the 3rd machine, it would keep a count and it would go away. So here we go. You'd stick that drive in machine A, it'd infect it. Machine B, it'd infect it. Machine C, come on, it would infect it. And then guess what? It disappears. So if you were to look at that drive on some 3rd computer, 4th computer, you would not find anything on it. I don't know why they did that. It doesn't seem like it had that much value, but they did. Number 2. This one's a very interesting one. Stuxnet's authors digitally signed the Stuxnet binaries, the executable files, with what are called digital certificates. And these were stolen digital certificates. So what is this like? You know, you buy software sometimes and you'll see that little holographic label. That indicates it's a real product. It hasn't been forged or something. Well, there's a way of doing that with cryptography. Do you guys have a crypto class yet? A crypto session? No? Okay. So there's a way of using what's called public key cryptography to automatically digitally sign, it's like digitally stamping with a hologram, if you will, a piece of software, so that if the software changes, you can detect it 100% certainty. And if the software is, and you can also determine who created the software. Okay? So typically, files that are digitally signed are thought to be trusted because you can actually trace them back to figure out who created them. And for instance, a company would never produce Stuxnet with a digital signature that it would stamp on it, because then you would know who the company was and you could go and sue them or something, or nuke them or something and take them out. Okay? But Stuxnet somehow used stolen digital certificates to make it look like it was created by well-known companies. Specifically, one company named Realtek and another company we'll see in a second. Now, as it turns out, J Micron was the other company. Realtek was one of the companies. Somehow, the people who made Stuxnet stole their cryptography keys in order to digitally sign Stuxnet so that it would look like it came from these vendors. It would look like legitimate software from these trusted vendors. And as it turns out, these vendors happen to be in a Taiwanese business park just a few blocks away from each other. Does that mean the people who created Stuxnet had spies there? Did they hack into their computers? Typically, these encryption keys are kept in vaults. They're not just on a computer necessarily, because they're, you know, if these keys are lost, people can impersonate software from that software company. It's really bad. So I wonder what they did. Why would they go after these 2 companies? Maybe they did something like that. I don't know. But you know, how can they get these things? You have to break into a vault to get these things off. And finally, number 1, Stuxnet conceals its malicious code changes to the PLC. So remember that PLC is that programmable logic controller, that special hardware? Stuxnet not only hides itself on the PC, it also hides its changes to the PLC. So this is sort of what it looks like. On the console where the Iranian managers would look, it would say, during normal operation, spin at 1064 hertz. And it would say, in case of emergency, spin down to 0 hertz, for example. Okay? But if you were to actually look at the logic on this device here, what you would see would be, during normal operation, spin at 1400 hertz, and in case of emergency, ignore operator commands. Okay? So Stuxnet actively concealed its changes from the operator, even if they looked at the logic. In fact, it's possible to actually get the logic off the PLC and look at it. Say, what's on this PLC? I want to see what data is on, or what programs are on this PLC. It would actually automatically disinfect or deinfect the software when it would bring it back up and show it to the operator, and then reinfect it when it put it back on. Okay? Pretty amazing. Okay? So it would hide its changes. Okay, so let's talk a little bit about how it spread. And did it succeed? Well, based on some clever engineering, again, I have to hand it to our guys. I did none of this, by the way. I just love to deliver the story because it's such a cool story. Okay? We got some really interesting data. So fact, Stuxnet, as it turns out, contacts two servers, at least that we know of, that are called command and control servers. A command and control server is a server on the internet. It's a big machine where and Stuxnet contacts these machines, which are controlled presumably or were controlled by the attackers, to get new commands, to get new updates, so it could update itself and so on. Okay. Now, where were these servers located? Well, they happen to be located in Europe and in Asia. And these were the domain names, www.todaysfootball.com, www.mypremierfootball.com. These were sites set up by the attackers entirely for the purpose of controlling Stuxnet. And every instance of Stuxnet around the world, as it spread, would contact, if possible, if it was able to, if it wasn't air-gapped, these two servers. Now, working with people called domain registrars, okay, these are people who actually control where these domain names go to, Symantec pulled some strings and redirected those two sites to our corporate headquarters in Mountain View. So we were able to see every copy of Stuxnet around the world contact us, so we could figure out where every copy was, at least ones that were on a network where they could reach the internet. Okay. Second fact, as Stuxnet spreads between computers, it keeps an internal log of every computer it's visited. So Stuxnet, this is like putting a notch on your belt. Okay? It actually remembers the computer that it visits, and if it visits 10 computers, it actually keeps 10 addresses inside of itself saying, I've been to these 10 computers. What does this look like? So imagine here we have 10 computers that it's spread to. Stuxnet comes to the first computer. It will actually take the IP address of that computer and add it to itself. It actually modifies itself and keeps a history of where it's been. When it spreads to another computer, so we have this copy here. This copy here is actually a slightly different copy because it has two IP addresses embedded in it, two internet addresses. Spreads to two other computers. Now you can see we have another version. So we can actually gather different copies of Stuxnet and figure out where each copy has been. And we can actually figure out a lineage that machine A infected machine B, infected machine C and D, and so on. Okay? And as you can see, some copies of Stuxnet will actually have many numbers, some will just have a few numbers, and you can see that we can actually trace this back, the lineage of the propagation. Okay? So based on both of these pieces of information, we were able to come up with the following. We believe that there have been actually 4 waves of attacks, probably. These are 3 that we discovered initially. And what you see here is that the people who started spreading Stuxnet did not go to the Iranian networks right away. What they did was they went to these obscured domains. These are companies that we're not showing you. I don't know what they are. I don't actually know the details. But they actually went to these companies. These were companies that were working with the Iranian enrichment facilities to provide them with technology and hardware. Okay? So whoever wanted to attack Iran went to the support companies that were actually serving Iran, the people, the workmen who would come in, consultants, and infected them first. The initial infections we've seen targeted those support companies, not Iran. Okay? Those people then went in and so on. And for each of these, there were different waves. Okay? The compile time is the time when the software is first created. That's when the software is actually created, by the compiler, by Visual Studio. Okay? And you can see the infection time. Okay? And you can see the time to infect. So you can see this first variant, they compiled it and built it, and within 12 hours, it was actually actively spreading on one of these victim networks. Okay? In some cases, it took days before they released a copy of the software. Maybe they tested it first. Who knows why? And in fact, we know about 3 waves, or we knew about 3 waves initially. We now know there was a 4th wave that was actually goes back as far as 2005. This is to 2009. Okay? That version was different. That version actually didn't try to spin things faster or slower, but instead what it did was it actually tried to close and open valves to create pressure differentials in the centrifuge enrichment facility that would cause breakage because the pressures would get too high. Okay? It was a different attack type. And it would also hide, by the way, that version would also hide those changes. So an operator looking at the status of the pressures would see normal pressures in all the valves, but in fact they were being raised. So this really goes back to 2005. I don't have that chart, unfortunately. It's new information we got, but I wanted to share it with you. And here are some graphs that show you the spread of Stuxnet. So here's the Gen 0. This is the first incarnation of the threat. And then you can see it hit this computer, this computer, this computer, and so on. These were probably different, the first generation computers, the very first computer in each of these consultant companies. And you can see each other dot is another computer that it spread to. So you can see the thing spreading because we have all that information embedded inside of the threats. These are copies we've actually captured. We've been given these copies by customers. Geographical distribution of infections. You can see Iran way up on the list there. Really got targeted. But other companies also got hit, or the countries also got hit. Now remember, Stuxnet wouldn't have done anything here because these countries did not have exactly the configuration of devices that Iran did. But it actually spread anywhere it could. You might have had Stuxnet on your computers, actually. And in fact, our security software detected Stuxnet and removed it without even knowing what it was. We actually automatically generated fingerprints to remove Stuxnet with automated computer systems that got the threat, realized that it was something bad, and made a fingerprint for it. So our products would have protected you in many cases, but we didn't even know what it was. Nobody actually had looked at it for months after that. And so we tried to protect our users, at least, for instance, in countries where we couldn't sell our products. And here you go, another slide. In Iran, these are systems infected that had Siemens software. So this is a case where the threat actually found its way onto an industrial control system, not just anyone's computer, but a computer that actually did control industrial hardware. And you can see most of the machines were in Iran. So did it succeed? Well, indications are that it did. Our telemetry indicates that rather than try to directly infect or infiltrate Natanz, the attackers actually infected 5 industrial corporations, as I told you about, that had ties to Natanz. They were subcontractors. And these companies likely then unknowingly or knowingly, there might have been spies, ferried the infection into the research and enrichment networks. And the Institute for Science and International Security writes basically that it's well accepted that roughly 1,000 centrifuges were disrupted. And I'm sure this actually caused them to go and reevaluate. Was there something wrong? Was there a bug in their software? Even if it didn't break the centrifuges or cause them to explode, people probably looked into this. So it probably did hamper the program. Okay, about 1/9. So who did it finally? Well, I know you're all waiting to find out. You ready? You're not. You're going to be very surprised. The Jamaicans. No, I'm kidding. They're known for their bobsledding. They're known for their bobsledding. So it is generally accepted now that the United States and Israel did this together. It's been not really admitted, but sort of admitted by people in the United States government. It's sort of like, well, maybe, I don't know, I don't remember the exact quotes, but it's thought to have originated from the United States and Israel. And I'll tell you one indication that may cause you to think that maybe it was created by, at least in part, by the Israelis. So when Stuxnet visits a new computer, Stuxnet actually has to make sure that it's not already running on that computer, because it's possible that when Stuxnet flows to your computer, and it gets there might be another copy of Stuxnet that got there yesterday. And it wants to make sure that it doesn't run twice in your computer, or 3 times, or 5 times, or 10 times, because it's constantly spreading over the network. So it doesn't want to reinfect computers. Okay? So what Stuxnet does is when it gets on a computer, it creates a little magic number in what's called the registry. It's a settings database. Okay? And it actually creates a number which is 1979-0509. Okay? So when Stuxnet reaches a computer, if it finds that number in the settings database, it says, I'm already here. I'm not going to bother spreading anymore on this computer. I'll just cease and desist. Okay? So it checks itself so it doesn't run multiple times. Well, guess what? If you're a conspiracy theorist, of course, like people in Symantec, you're going to Google this number. And what you're going to find is that on Wikipedia, which is a source of truth, of course, we all agree, okay, that on May 9th, which is 5/9, 1979, a person was executed by a firing squad in Tehran. Okay? And it actually was very disruptive to the Jewish community there. He was the first Jew and one of the first civilians to be executed by the new Islamic government. And this prompted the mass exodus of more than the once 100,000 member strong Jewish community of Iran. Okay? And the exodus continues today. So we don't know. This could have been somebody's birthday for all we know. Okay? But it was interesting that this number was used. And if you're a conspiracy theorist, you might say, oh, maybe this points to the Israelis. But there's more evidence. In every executable file, okay, every file that you create with Visual Studio, for instance, okay, because you're programming with Visual Studio, there's a timestamp. And that timestamp is what's called a GMT timestamp. This is basically Greenwich Mean Time. This is the British time, basically. Okay? And this is it's called universal time. It's a central time here. And so if you look at these files, you will find in every one of these files some timestamp of when the software was first created. Now, something I didn't know, which I learned when I started giving this talk, when I started putting this all together, as it turns out, Visual Studio also embeds a second timestamp in every file. It's a little bit, it's hidden. Most people don't know about it. And that second timestamp is actually local time. Okay, local time means it's in the local time zone. So for instance, the local time zone would be 1:45, Greenwich Mean Time would be 9:45, Okay? So we can see that it's 8 hours difference. Okay? Now, if you look at the GMT time in one of the files we captured and the local time in one of those files, and you take the difference between these, you see they're exactly 2 hours apart, GMT plus 2. That means it defines a strip across the globe, north to south, of a set of countries where this was probably compiled. Although this could have been forged. It could have been forged. But if they didn't know about it like we didn't until we found this out, guess what strip that is? And guess what country happens to be right there? Israel. Also South Africa, so they could have done it too. But it probably Israel. Okay. So, to conclude, and I'll take questions, Stuxnet has signaled a fundamental shift in the malware space. So we have now seen attacks that don't just steal your credit card numbers, okay, or disrupt your computer, or encrypt your files. These are attacks that will literally take out physical infrastructure. They will literally cause destruction. And by the way, there's no reason why Stuxnet couldn't have been used on a power plant. Power can go out right now. No reason that Stuxnet couldn't have been used on a hydro facility, okay? And these facilities are far less well defended than enrichment facilities. So we've now seen a shift from cyber espionage, stealing information, to cyber sabotage, which is a fundamentally new thing. Stuxnet proves that cyber warfare against physical infrastructure is feasible. Okay? And again, it sort of opens Pandora's box, but let's be honest. If the Israelis and the United States didn't do it, somebody else would do it. So it's good that we know about it, and at least we can try to defend against it. And unfortunately, the same techniques, as I said, can also be used to attack other physical and virtual systems. So it's going to be a very interesting world. So computer security is actually a really interesting field to be in, and I would invite some of you, as you take your classes, we have internships at Symantec and at other security companies. Come join the world of computer security, do something great for the world, and actually protect the world's computers. Because it's a noble thing to do, and you can see you can actually have a real impact. And with that, I'll take questions. Yes?
How'd you guys first find Stuxnet?
So as I said, we received it without our knowledge. One of our automated systems processed it, determined that it was bad, fingerprinted it, so our product would detect it and protect against it, and it went into a collection that nobody ever looked at. And then, months later, somebody contacted us because they, for whatever reason, had been doing an analysis of the threat. And they said, this is not the average threat. It's actually much more complex. And we looked and we said, oh, we got this months ago. We have protection. But we said, well, let's look into it. And then we started analyzing it and we saw, ooh, this is more interesting. We looked a little bit more. It took them months. And then finally we realized, wow, we didn't even know what we had. Okay? You had a question, right?
Oh, yeah. To infect the USB drive,
yeah.
When you put it in the computer, would it automatically go onto it? Or would someone have to activate
Yes, it would automatically infect the USB drive, just sticking it in the computer, boom, it goes onto it. Yeah.
Why did your software protect against it?
Why did our software protect against it?
Yeah,
Because we created a fingerprint for it. So at least some of the variants would automatically be detected. We knew what they looked like and we would stop them. But again, the Iranians were not using our software, it was export controlled. Yes?
Stuxnet can be updated from command and control servers and also remotely controlled by them. What prevents it from being used against, what prevents like the command and control servers from being switched from targeting these entities to targeting anything?
Look, there's nothing that prevents somebody from taking Stuxnet and going and modifying it to do other things. It's actually easier to create a threat from scratch than it is to modify Stuxnet because it's so complex. Okay? What it does is it shows that things are possible, but it's not necessarily going to be the template for these other attacks. And by the way, all the attacks that it used are now known. So if it were to spread with those 7 techniques and so on, it's not going to be nearly as effective. Yeah. Other questions? Okay. Well, hopefully I'll see some of you. Anybody? Yes, question?
When you control the registrars for the attack,
No, well, remember, the Stuxnet is actually capable of spreading autonomously. It doesn't require those domains, the command and control domains, to actually spread. So we were able to monitor it. I don't know if we were actually able to stop the infections by sending a cease and desist or not. I don't know the answer to that, but there's nothing that prevented them from continuing to spread after that point. It's totally autonomous. Other questions? Okay. All right, well, hopefully I'll see some of you next quarter, and I appreciate your time.